What if alchemy wasn't just a myth from the Middle Ages? What if scientists today actually managed to turn lead into gold? Well, they just did. In a breakthrough straight out of ancient legend, researchers at CERN have accomplished the impossible using particle collisions. They've successfully transformed lead into gold atoms. This isn't magic, it's nuclear physics. Let's break down the science behind this modern-day alchemy, and whether it could change the world. For centuries, alchemists dreamed of transmuting base metals like lead into precious ones like gold. They believed that with the right elixir or magical formula, lead could be purified into something more valuable. It wasn't just about wealth, it was about discovering the secrets of nature. Of course, we now know that wasn't scientifically possible, at least not with chemistry. But physics? That's another story. The idea that one element could be turned into another is no longer fantasy. It's now a scientific fact, under the right extreme conditions. This shows how ancient curiosity continues to echo in modern labs. At the Large Hadron Collider in CERN, physicists with the ALICE experiment did something remarkable. They smashed high-energy lead ions into each other at nearly the speed of light. These collisions are so violent, they can knock protons off the atomic nuclei. In the process, some lead atoms lost enough protons to literally become gold atoms. Yes, gold was created in a lab. Think about that for a second. Something once considered myth has become scientific reality. Though the main goal was to study quark-gluon plasma, a form of matter thought to exist just after the Big Bang, this side effect caught everyone's attention. The findings were recorded through precise measurements of the particles produced, confirming that lead nuclei had transmuted into gold. It was a tiny event in a massive experiment, but a historically symbolic one. Let's dive deeper into atomic structure. Every element on the periodic table is defined by its atomic number, the number of protons in its nucleus. Lead has 82. Gold has 79. If you remove 3 protons from lead, the atom becomes gold. This is called nuclear transmutation, but achieving this is no small feat. The nucleus is held together by the strong nuclear force, the most powerful force in nature. The collisions in the ALICE experiment create conditions similar to those in the heart of a star, dense, hot, and full of high-energy interactions. That's how protons can be dislodged. Gold formation was confirmed by tracking decay signatures and identifying stable isotopes produced post-collision. The researchers weren't just speculating, they had real data. Here's where things get humbling. The total amount of gold created? About 29 picograms. That's 0.000000000029 grams. At a production rate of roughly 89,000 atoms per second, it would take millions of years to produce a single gram of gold. This number comes from measuring the frequency of atomic transformations across trillions of collision events. It's a marvel of detection technology and statistical certainty. Other experiments in the past also achieved transmutation, such as in nuclear reactors with mercury or bismuth, but always at similarly impractical scales. The gold created at CERN is detectable, but not collectible. Still, its significance lies in proof of possibility, a breakthrough in scientific achievement. So why does it matter if we made a microscopic speck of gold? Because it proves something bigger, that we can intentionally alter matter at the nuclear level. That opens up new paths, not only for particle physics, but for industries like energy, medicine, and waste reduction. Transmuting radioactive isotopes into more stable ones could dramatically improve how we handle nuclear waste. And targeted nuclear reactions are already used in cancer therapy and material engineering. This experiment adds to that toolkit, expanding what's scientifically possible. It's a small step in the lab, but a giant leap for nuclear science. Now let's take a cosmic step back. Most scientists agree it forms during neutron star collisions and supernovae, events so powerful they can fuse heavy elements. In 2017, gravitational wave detectors observed such a collision. It was followed by a burst of light indicating gold and platinum formation. That event confirmed theories about the R process, a rapid neutron capture reaction that produces many of the universe's heavy elements. CERN's experiment is a microscale version of this process, showing us how the universe builds complexity from violence. And it bridges the gap between cosmic history and laboratory science in a beautiful way. Let's imagine a world where this process could be scaled. Right now, it's incredibly energy-intensive. Creating 1 gram of gold in a particle accelerator would cost far more than gold's market value, possibly hundreds of millions of dollars. But in the future, maybe. If compact particle accelerators or energy-efficient methods become reality, nuclear transmutation could be applied more broadly. Energy advances like fusion power or superconducting magnets could reduce costs dramatically. For now, though, this remains a scientific milestone, not a practical production method. This experiment raises profound philosophical questions. What defines value? Gold has always symbolized wealth, purity, and immortality. But what happens when we can make it in a lab? Does that change its meaning? The story of gold, from stars to atoms to human hands, is a reflection of our endless curiosity. And this experiment shows that while we may not always get rich from science, we do get wiser. It's a reminder that the true value isn't in the material. It's in the discovery, the process, and the perseverance. In many ways, this experiment closes the loop on one of humanity's oldest scientific pursuits. Alchemists once believed it was possible to turn lead into gold. Now, centuries later, physics has proven them partially right. Not with spells or potions, but with particle beams and detectors. And while we won't be minting lab-grown coins anytime soon, we've shown that transformation at the elemental level is real. The alchemist's dream lives on, not in gold, but in knowledge. It's proof that no idea is too old or too strange to explore again with better tools and better minds. So what if scientists turned lead into gold? They just did. And in doing so, they've connected ancient dreams with cutting-edge science. This experiment shows how curiosity, persistence, and technology can achieve what once seemed impossible. It reminds us that science is about wonder, about chasing the questions that others gave up on. If you found this fascinating, like, comment, and subscribe to BrainSpark for more science stories that feel like sci-fi, but are entirely real. Stay curious.